Question 15, part A. Just try and relate this to something that we looked at in class quite recently. If you see something like this, we're going to use this in this question in a minute. You've got to do 9 to the power of a half and x to the 6 to the power of a half. So 9 to the power of a half, which is the square root of 9, would give you 3. And using the laws of indices, x to the 6 to the half means you times these. 6 times a half will give you 3 as your indices. So you're doing this to the power of a half, and you're using the laws of indices on this bit. Well, here it gives you the cube root of all of this. If you cube root something, that is to the power of a third. So if we do this separately, because this up here is 9 times x to the 6. So I know we show the time sign in between here, but it's the same thing. You've got two different terms. So we can do 8 to the third, the cube root of 8, which gives us 2. And then if we do this bit using our laws of indices, we would times them. So 6 times by a third gives me 2. So 2 times 10 to the 2. Find the value of, alright, well 2 times 10 squared, 2 times 100 gives you 200. It's not asking you to leave it in standard form or anything, so we'll leave it as 200. Part B, find the value of 144 to the half. Well, that's just the square root of 144 times by, now 64 to the minus a third. A minus never makes it more difficult. All the minus does is it flips it at the end. So 64 to a third, the cube root of 64 comes out as 4. So if you put a minus sign in the indice, all that does, work it out without the minus sign and then flip it. The minus sign, all it does is flips it. So 4 becomes 1 over 4. If it's a fraction, the minus sign will just make it flip. So 64 to the minus a third is 1 over 4. So we've got, coming back over here, we've got root 144 times by a quarter. That's 12 times by a quarter. If you find that confusing, you can either, when you times a fraction, it only affects the top, so it becomes 12 divided by 4, which is 3. Or when you times, it's the same as saying a quarter of 12, which also gives you 3. So your final answer for this one should be 3. Okay, this one, 3 to the power of 2x gives you 1 over 81. Right, doing this in stages, 3 to the power of 4 is 81. So 3 to the power of minus 4, remember what we said about the minus as an indice, it just flips it. So over here, let's do 3 to the 2x equals, and instead of 1 over 81, let's think of it as 3 to the minus 4. Now looking at this, if 3 to the 2x is the same as 3 to the minus 4, well, if they're equal, these two indices must be equal. It's the only way this can work. So 2x must be the same as minus 4. So if 2x equals minus 4, divide both sides by 2. X must be minus 2. Okay, let's do question 16 at the same time. The probability that Sanne is late for school tomorrow is 0.05. The probability that Jaden is late for school tomorrow is 0.15. So Alfie says, a shout out for Alfie there, Alfie says that the probability that Sanne and Jaden will both be late for school tomorrow is 0.0075, because 0.05, so he's saying you just times them together to work out the probability that they're both late. Right, what assumption has Alfie made? Well, if you want to find the probability of rolling a 6 on a dice, it's 1 over 6. This is completely separate, this is just to lead into this question. If you want the probability of getting heads when you flip a coin, it's 1 over 2. Now if you wanted the probability of rolling a 6 on a dice and getting heads when you flip a coin, you times them together to get this probability. But the only reason that works is because the probability of rolling a 6 on a dice is not affected by the probability of getting heads on a coin toss, and vice versa. So we say that they are independent of each other. One of them does not affect the other. That is why to find the probability of them both happening, you can just times them together and get a final answer. Now this is not related to this question, so I'm going to scribble it out and come back up here. So for it to be true that the probability of two things happening can be calculated just by multiplying them, that can only be done if two events are independent. So the probability of one of them happening is not affected by the other. So if you will just briefly ignore that annoying noise in the background, what assumption has Alfie made? Alfie has assumed that the events are independent. So, because I cannot be bothered writing this all out again, you'll just have to put up with the noise made by my very annoying washing machine. Alfie has assumed that the events are independent. You can only times probabilities together like this when events are independent, when one of them is not affected by the other.